In this video, we're going to be learning how to factor and recognize the difference of two squares. But I always want to caution you, when you see the word factoring, you need to always think about that greatest common factor. But let's just look at the goal we have, the difference of two squares. The word difference means that there's subtraction. Two means you have two things, and these two things are perfect squares. Again, to review your perfect squares, that would be like 1, 4, 9, 16, 25, etc. So the way you factor the difference of two squares is you have two binomials where a times a is the first square, b times b is the second square. One has a plus sign, one has a minus sign. It's really very easy. So let's look at this first example. I don't see any GCF, but I do recognize it as two perfect squares with a minus sign between it. That's very key. You have to have that minus sign. So I know I'm going to put two parentheses. I'm going to put one plus and one minus. And then I'm going to ask myself, what times the same thing is 25x squared? And of course, that's 5x times 5x. And then we want to ask ourselves, what times the same thing is 81y squared? And of course, that's 9y times 9y. And the last thing you want to look at is, can you keep going? Are these factorable some more? No, we're done. So as we're looking at the second example, again, I do not see a greatest common factor. I do see a minus sign. Now that x to the fourth, that still is a perfect square, because remember, x squared times x squared is x to the fourth. And 4 times 4 is 16, and of course 1 times 1 is 1. So I do believe this falls into that category of the difference of two squares. So I'm going to put my parentheses, plus minus. Yes, you can do minus and then plus. I just have a habit of doing my plus first. What multiplies times the same thing to get 16x to the fourth? Well, we know 4 times 4 is 16, and just as I talked about over here, I know x squared times x squared is x to the fourth. So 4x squared times 4x squared is 16x to the fourth power. 1 times 1, of course, is 1. Are we done? No, because this is also the difference of two squares. This is not because of the plus sign. So on the next line, you would want to bring down the 4x squared plus 1. We want to keep that as part of our answer, but this we need to factor further. So we have two more parentheses because that's the difference of two squares. Again, I like to put my plus and then minus. What multiplied by itself is 4x squared. 2x times 2x, and of course 1 times 1. And once again, can you go any further? No, those are all prime factors. We're done with that one. So let's look at this third example. 50. That's not in my perfect square list, and neither is 2. So maybe you just should put prime. No, because you need to look for that greatest common factor. And sure enough, 2 and 50 are both divisible by 2. So again, I'm going to divide both of these by 2, write down that 2, and I have x squared minus 25. Now, can I keep going? Yes, because that's the difference of two squares. So on the next line, we would bring down that 2, and we'd have that plus and minus, and of course x times x is x squared, and 5 times 5 is 25. That's the correct answer. Skipping this step is a bad idea. Right? You cannot skip this step. The reason is because you just really shouldn't go from there to there. Showing your steps, thinking logically, is part of learning math. So let's look at this fourth example. That looks a little bit different. Now all of a sudden I have binomials to factor into probably binomials. Well, what I want you to notice is that you still have something squared. You still have a minus sign, and of course you know that 3 times 3 is 9. So that's still the difference of two squares. So I'm just going to make my parentheses a little bit bigger, put a plus and a minus. Let's start from the one that looks the easiest. What times what is 9? 3 times 3. But that goes at the back side of the parentheses. And this really first part is actually the easiest because it's saying x plus 2 squared. Well, what squared is x plus 2 squared is x plus 2. But we don't want to leave our answer like that. But let's just kind of check. We have x plus 2 times x plus 2 is x plus 2 squared, and 3 times 3 is 9. I can't factor further, but I can clean that up. And so I'm going to collect like terms. We have x plus 2 plus 3 is a positive 5, and here we have a positive 2 and a minus 3 is a negative 1. And that is your final answer. So let's just kind of do one more of those with a few more letters. Again, hopefully you can see that this is a perfect square, that is a perfect square, and we need to factor that as the difference of two squares. All right, so just like the fourth example, this goes here, 3x minus 2y times 3x minus 2y is going to be 3x minus 2y squared. Then what times what is 49z squared? 7z times 7z. Now, unlike the last one, there's no like term. So you could leave your answer like that, or you could take out some of those parentheses. They're really not doing anything. I just like to use them to show you where that came from. So that would be your final answer to number 5. So let's look at number 6. Wow. Yeah, I see a minus sign, but I see lots of other weird things. Remember, we always want to look for that greatest common factor. So if you go way back to when we were talking about greatest common factors, sometimes those are not monomials, sometimes they are binomials. So they both have 5x plus 4 in common. I'm going to take out the 5x plus 4, and remember, we're just dividing both of these terms by 5x plus 4. So if I divide that out, and write down what's left, I have x squared minus 9. That's how we factored a few days ago on greatest common factoring. But here, we're not done yet. That is the difference of two squares. So once again, I want to bring down the 5x plus 4, and then I want to factor this further. And then I want to look at that and see if can I go even further. I don't think so, so I'm done. And notice I'm going line by line. Do not put all of this on one line of notebook paper. Do one step per line. Makes it much more organized that way. So what I'd like for you to be able to do is factor x squared minus 100. And then, how come, even though this is not the difference of two squares, because there's a plus sign, it is not prime? Remember, prime means it could not be factored any further. Let me give you an example of something prime would be something like x squared plus 5. That cannot be factored further. X squared minus 5, even though there's a minus sign, it's difference, but 5 is not a perfect square. So primes are things that cannot be factored at all. But this one is not prime. I want you to figure out how you could factor it.